Here we go. We are going to start looking at properties of substances. And you can kind of see in the picture, we're going to be doing something to do with lava lamps today. And so before we get started today, your at-home materials, you're going to need some vegetable oil, corn oil. I haven't tried olive oil, but it probably works as well. You want some water. You need a clear, a tall container. So for example, I'm just using a large jar. But you can also use a water bottle, which is pretty easy. Need some food coloring and some Alka-Seltzer tablets. So what we're going to be looking at is we have our jar and we have our water. And so what we want to do is we don't want to fill up the jar all the way. So the water is about less than half. Okay, we don't have any precise measurements. Because it all depends on your container that you're using. So you want just less than half. And you want to add, you're going to add oil, and you're going to add about the same amount in your jar. And so before we get into those pieces, we definitely want to ask students, what are you noticing and what do you wonder as I pour the oil into the water? And so we are going to go ahead and do that. And so they can definitely see that something's going on here. And we also definitely see some separation. And as we get into the older grades, we are definitely going to get into density and what's going on with density inside of our container. And so second grade starts chemistry, and they look at properties, physical properties. So we definitely can say, well, this one's on top of this one. So this, and we know that this is water and this is oil. So something's going on here. And so they don't need to explain explicitly that, oh, this is density. No, we just want to show that there's certain properties that's separating this piece from this piece. So then what we do is we want to add food coloring. You can use any type of food coloring you'd want. And if you look at it, we can see dots and then what's going on there. So we see something's going on with that red food coloring right in the middle. And why did it go to the middle? I wonder why it did that. So there's definitely a lot of inquiry questions that we can ask students about this experiment. All right. So now what we're doing is we are going to add an Alka-Seltzer tablet. So we know that when you add this to water, what happens? You know, and you can show it with just water. So if I add this to this piece, is it going to float like the food coloring? Is it going to sink all the way to the bottom? And then what's going to happen with it? So you can either use a full tablet or a half tablet. I, with a class, like to use a half tablet because you'll see with the chemical reaction that's going to happen that I can have twice as much fun instead of just one time. So it kind of extends the experiment a little bit longer. Now we can also, besides physical and chemical properties, we can get into changes, physical versus chemical changes. So we can say, okay, we added the oil to the water. Is this a physical or chemical change when we get into middle school, or not even just middle school, fifth grade? Fifth grade starts to look at physical and chemical changes. And so when we add these pieces, what's going to happen? And normally by now, that bubble of food coloring would be popped right now. But let's see what happens. So we're going to take our half of our Alka-Seltzer and drop it in. And then you can kind of see what's going on. So our Alka-Seltzer tablet is down at the bottom. Our red food coloring bubble popped. But then you notice what's going on here, okay, within our oil. And so when we go over chemical and physical properties or changes, we like to talk about is, can we actually get that Alka-Seltzer back to being what it normally was? And obviously the answer is no. So that's going to be definitely a chemical change because the chemical properties of the Alka-Seltzer have changed. But if you notice, it starts to slow down. So after a couple minutes, after students have written down their observations and looked at how the molecules are moving, I'll say, all right, drop another one in. And then we get to see even more happen. Students love this. You can definitely do extensions on top of that, and we'll go over that in a minute. And then, of course, your materials are pretty easy because most people have these items at home. And then we want to talk about the science behind the experiment. So this is a great, again, opportunity to go over chemical properties and physical properties. So starting in second grade, they go over those physical properties and how to use products, even if it's just a simple craft stick. How do I use a craft stick to build, or what's its durability? So that's second grade, that begins chemical or chemistry. And then fifth grade, we're looking at making observations and measurements. So we definitely made some measurements and we're able to observe those materials and how they changed with their properties. And then as we get into middle school, we start to look and analyze, interpret data on those properties of substances. So looking at the data of the oil and the Alka-Seltzer and the water itself, and figuring out before and after the experiment and how those substances have changed. And so this is a great introductory piece to show if you were going over those standards. And so I've given you an example of how it works and what happens with the gas bubbles, with the carbon dioxide, with the food coloring, and how that can change, or how it just stayed in the middle, and the reason behind why it stayed in the middle. And that, of course, has to do with the density of the food coloring and the water are the same. And that's why the food coloring, if you notice, did not move up and change that oil to red. And so we are looking at multiple things, multiple science concepts just within this one piece. And again, we can get really deep into density with those. Why do students love this activity? It's just a great demonstration for students. They get to do it. They get the hands-on piece. And this starts chemistry. This is fun for chemistry. And kids would always love to do extra chemistry experiments. And as a teacher, they always want to do vinegar and baking soda. Let's make volcanoes. And I'm like, did you know that there's so much more chemistry out there that's safe chemistry that we can try besides vinegar and baking soda? And so this is just another great piece to add to your skills and your toolbox. And so again, jumping into middle school standards, we can definitely get into density and buoyancy, and then start sketching and looking at how those molecules move, and even shaking up that container. Well, I had a lid on, and I could shake it up and we can see what happens as the two pieces try and mix. But of course we know they're not going to mix. But definitely they love to shake them up and go, I want to see what happens. And then it goes back to this within so many minutes. But it is a great standard to start looking at how those molecules are moving. So as an extension to the experiment, we can kind of have an idea of, well, what if we took the whole tablet and dropped that in? What would happen? And when it does stop to bubble, what if we added some salt to it? What could happen? Because that's something else that we have at home too. And then what if we added some glitter? Okay, we have 4th of July coming out. What would happen if I dropped this in and we added some glitter to it? Would the glitter float up? I mean, and glitter, depending on its density, is it going to just sink to the bottom? What's going to happen? So we definitely can add some more pieces to our experiment and find out more about lava lamps. So that's it for me. Thank you.